All right, let's do our sample project. So we've plugged in our PSoC kit, but we want to make sure that the firmware for the programmer is all set. So we just open up PSoC Programmer, just click on the kit, click on Utilities, and upgrade the firmware. I've already done this, and if you don't, you'll get a error, kind of a error warning message in Creator saying that one should do that. So we'll just minimize that, and we'll start PSoC Creator. And it might look a little bit different than yours because I've been using it. You won't have the recent part here. But you want to open up a project workspace. And this project here, the breathing LED, this won't be in the same location for you as it is for me. It'll be where you installed the CY8CKIT-043 kit. You just have to go through. So I put it in Dropbox. Right, that's where it installed everything. That way I can work wherever I feel like it. All right, I'm going to open it up. And here we go. So we see there's all these files here. That's everything we need to do. And when we click on this tab here, we see the pins. And we have the pin stop, right, which will be a switch. And we have the LED that will blink with the breathing pattern. But this is what with the actual chip and where the pins are. Okay, and the kit basically has an LED connected to port 1, pin 6, and port 0, pin 7. The actual pin of the chip would be 64 and 46. To see what else is involved, all right, besides just the pins, we can click down here in the analog block, of which it's not using any, but those are all the analog blocks we can use. We have direct memory access, clocks, right? We can interrupts, the system, directives, and something very interesting is that when you program your microcontroller, you don't want, and you're trying to make money at it and sell a product, you don't want people to reverse engineer, so you can encrypt your code on the chip. So even if they have the chip, you know, at this time, they can't get your code. There's a schematic, and this is, you just click on top design over here, and we have a clock, a PWM clock, and it goes into 2 PWM drivers. And what's interesting is pulse width modulation, right? It just changes how long something is on for, right? So we have all these various things. It's set to PWM here, and we give it a period of 200 cycles, and it compares at 100 cycles. PWM, pulse width modulation, is a whole other thing. This pulse width modulation unit has a period of 198 and 99. And so I have it kind of a little small here. But basically, these clocks only align every 19,800 clock cycles, all right? And we have an exclusive OR so that only one can be on for it to be high. That goes into an AND gate that if you press a switch and tie it to ground, the LED will not be lit up. Right. For an AND gate, all inputs have to be high to get a high output here. The XOR, only one can be high. to get a high. So that's all of that. Now, the original clock frequency here of this PWM clock is, like I said, 19,800. Now, we're just going to go through the building process. We're just going to build it. We haven't made any changes. It's pretty quick. All right, everything's successful. Now we want to program it to the microcontroller. And so we're going to click right here. And now the code that we've compiled will go to the microcontroller. Now I have port acquire failed. And that is because I did it on purpose. I forgot to close PSoC Programmer. All right, and it was even giving me a warning, and I was just ignoring it. Maybe you picked it up. So now we'll program it properly. And basically, there's no change in the blinking pattern. I can make another video to just show how these go. But again, there shouldn't have been any change in the blinking pattern because we hadn't changed anything. But now let's configure the PWM clock. And we're going to right click and click configure, and then we have a frequency here. Well, I'm going to cut it in half approximately to 10,000. And a little thing, because it's just such a simple change, I can just click program right there. Alrighty, and now the breathing pattern is about twice as slow. Now again, in general, these blinking things are happening so fast that it just looks like it's smoothly raising up and coming down. But if we really slow it down, for this clock, the slowest we can go is about 800 Hertz, and reprogram it. You can actually see it blinking off and on. Then as the clock cycles become aligned, or unaligned actually, you get a longer and longer high period. And you'll see it blink. It'll seem like it's blinking faster and faster to where all of a sudden it is like a solid bright blue. And then it starts blinking slower and slower. So, you know, things you could do is right now if I press the switch, it stops going. Maybe I could change logic gates here where I press the switch to start it going. Right? There's other patterns you could do by, like I said, configuring the periods and the compare. But that's pretty much the first project that comes with it. We've changed the clock, changed this blinking rate, and yeah, we haven't used any C code. Let's go over here and click on main.c. The only things we do in the C code, and this is written for you, this was written for you, it won't generate. You'll when you do your own projects, you'll have to do this. But you just start the first pulse width modulator, start the second, and then this is kind of puts the CPU to sleep, which means this whole blinking thing does not need the CPU. The power in a CMOS chip is equal to an activity factor times the frequency times the capacitance that's being charged and discharged times the power supply squared, And so if you can change the activity factor to 0, well, you won't use any power. So that's why I think PSoC has a real advantage, is that it can completely turn off the CPU and still do other things. And that's it.